Good day. I hope we're all doing well. In this first discussion video for Math 23 for Lecture 1.1, we will be solving some examples regarding functions of several variables. Okay? First, some reminders. If you haven't watched the lecture video on this topic, then please do so before proceeding, because for the rest of this video, we will be doing some or all of the lecture exercises at the end of slides for that topic. No? Also, if at any point you would like to go back to a previously discussed topic, you may pause this video and go to that part of this discussion. Okay? Let me just introduce the general flow of our video. For the first part here, we will be finding and sketching domains of functions, which will arise from restrictions on the respective expressions here. For part 2, we will be looking at this function and sketching its domain, graph, and range. And for the third part, we will be looking at level curves and level surfaces. Okay, so we will be sketching some such curves and surfaces. Okay. All right, so let's start by looking at the domain and its sketch for f of xy equal to x squared minus y minus 1 under the square root all over x squared minus 1. Okay. So we will be looking for all ordered pairs of real numbers such that first, if we look at the numerator, we have a square root here. So the radicand, this x squared minus y squared minus 1, must be non-negative. That's the first restriction. And for the second one, we have the denominator. It should be non-zero. Okay? So we will be solving this inequality by moving the y to one side and rewriting the inequality like this. So we have y less than or equal to x squared minus 1. So we will be locating this region later. Furthermore, we will apply the restriction that your x must not be plus or minus 1. Okay? So graphically, we will be representing that exclusion of 1 and negative 1 for x. Okay? Here we have our Cartesian plane, and we will be sketching this domain of f. First, let's start with the parabola from this inequality. This is an inequality, ano? So we will start with the equation form, y equal to x squared minus 1 like this. Since we have this now, this curve, and since we have less than or equal to, we will be including this curve here. Okay? Now, this curve divides the Cartesian plane into two regions, the one inside the parabola and the one outside. So to know which one we will be shading later, let's take a point on the Cartesian plane. Let's say this point, 2, 0. And let's test it if it will satisfy the inequality. Okay, so we will plug in x equals 2 and y equals 0, and one can check that the inequality is satisfied, so that we will be shading the portion or the part of the plane containing 2, 0 to signify that it is included in your domain. So we shade this region outside the parabola. Okay. Now, for the other restriction, we should have x not equal to plus or minus 1. So we will remove all points whose x coordinate is 1 or negative 1, resulting in these two dashed lines here. And that is going to be the domain of f visualized. So this orange region here with these two dashed lines. Okay? So that is exercise 1. Now, let's go to exercise 2, where we have the function arc cosine of y over square root of 4 minus x squared minus y squared. We will be looking at its domain. So, usual thing, we will take all pairs xy satisfying the following. First, this arc cosine, we know that it has a domain, and its default domain, it's going to be -1 to 1, with the property that its arc cosine must be a real number. So doon manggagaling yung -1 to 1 for y later. Furthermore, we must have the denominator. It involves a square root here, so it should be non-negative at first. But since it is in the denominator, we remove the possibility that it is equal to 0, which gives us this inequality. Okay? And now we solve for x and y satisfying those properties. The first one gives us y between -1 and 1 included, yung endpoints. And as for the second property here, we have this inequality, which is based from, well, if we check, that looks like x squared plus y squared equals 4. So we will be taking some region defined by a circle centered at the origin, radius 2, like this. No? So it's either the inside of the circle or the outside. And furthermore, this boundary is dashed since the inequality does not include x squared plus y squared equals 4. Okay? Now, let's put the restriction that y is between -1 and 1, which is represented by these two horizontal lines. So we have y between -1 and 1, and this inequality suggests that we take the interior of the circle. You could test that the point 0, 0 is on the interior and it satisfies this inequality. Okay? So all in all, we will be taking this shaded region here between the two lines and inside the circle. Okay? And let's just remove the dashes to finalize the sketch of the domain of G of xy. Okay? So that's exercise 2. Now let's find the domain of this function, ln of xy. For this one, we will need the restriction on the domain of ln, since it's the main function here. So for the domain of h, we will take all ordered pairs xy such that the output of xy, remember, since it is inside your ln, it must be positive, since ln only takes in positive real values. Okay? But if xy is positive, then there are actually two possibilities for that. It could either be the case that both x and y are positive, or that x and y are both negative. So in other words, x and y must have the same sign, both positive or both negative. Okay? And graphically, we obtain the following sketch. We include the coordinate axes in the sketch, but they are dashed. Okay? Again, that's the case since we do not allow for equality. So x and y cannot be 0. Or rather, x or y cannot be 0. Okay? And finally, we have x and y greater than 0 for the first case. So all such points with that property lie in quadrant 1, like this. Also, for x and y less than 0, all such points with x and y negative lie in quadrant 3. So that's going to be the domain of h of xy equal to ln of xy. All right. And finally, let's take a look at this function of 3 variables. We have the arcsine of x plus y plus z. Well, for this one, we will be needing a region in 3D space since we have 3 variables. No? So let's take the domain of this function as the set of all ordered triples now, x, y, z, such that this quantity inside your arcsine, x plus y plus z, is bounded by the usual domain for arcsine, which is between -1 and 1. So we have that inequality. And here it will be convenient for us if we solve for bounds for z. Okay? Since z is present here, it might help us if we know some bounds for z. In particular, we can take the difference of all sides when we subtract x plus y from each side. So if we take away x plus y here, sa gitna, z na lang yan. On the left, we get -1 minus x minus y. And on the right, we get 1 minus x minus y. And that is going to be the domain of capital F. Okay. Now for the sketch, we will be needing here some 3D sketches, no? Because in particular, we have an inequality or a continued inequality, which when split in two, suggests that we have to draw some planes, no? Because, for example, this one, z equals, if we remove the less than, z equals 1 minus x minus y, it represents a plane, no? And if we recall how to sketch your planes in 3D from Math 22, then you may want to start with, of course, your 3D space. Next, we can plot some intercepts of the plane z equals 1 minus x minus y, like this. They are 1 unit away from the origin. Itong tatlong dot na to. No? They are 1 unit each away from the origin. So it forms a triangle which forms a plane. No? And that plane is this plane in yellow. It's an extension of the triangle between or connecting the 3 dots. No? Now we can do a similar solution for z equals -1 minus x minus y. That's the other plane coming from the left-hand inequality here. And if we draw those intercepts, we can now put this blue plane, which is the extension of the triangle, through the lower 3 dots here. Ayan. It might not be visible from this angle, no? But the actual domain now will be the region or the 3D region between the 2 planes to suggest that z is between the yellow plane and the blue plane. So let's remove the dots there and there. So the region between those 2 planes is going to be the domain of capital F equal to arcsine of x plus y plus z. Okay? And that's how we look for domains of functions of more than one variable using the usual restrictions on the functions involved in your original function, no? And that is part 1. Okay. In the next part of this video, we will be solving now for these 3 items. Okay. So you may want to try them first before viewing the next part of this video. All right. Thank you very much, and I'll see you in the next part of this discussion video.